Hello students, in this video we'll discuss one of the simplest criterion under which a Fourier series will converge absolutely and uniformly to the function in question. So let's suppose that f maps negative pi to pi into c is a periodic function, is a 2 pi periodic function such that the sum n in z of f hat of n, the sum of its Fourier coefficients are absolutely convergent. Then Sn of f of x, which is the convolution of the Dirichlet kernel with f, which is the n Fourier partial sums, converge uniformly to the function f. Okay, excellent. So there's the uniform convergence over here. And of course, these are just the partial sums of the Fourier series, partial sums. Just the sum over j less than or equal to n f hat of j e to the ij x. Excellent, okay? Now, how do I show something like this? Well, we're going to use the Weierstrass M-test. So recall, this is the Weierstrass M-test. And what that states is the following. It states that if I have a sequence of continuous functions which are, so states the following, so if fn, n goes from 1 to infinity, is a sequence of continuous functions such that the absolute value of fn of x is less than or equal to numbers mn on an interval ab for all x on the interval ab, and the sum n goes from 1 to infinity of the mn converges, then the infinite series, then the sum n goes from 1 to infinity of fn of x converges uniformly to a continuous function, converges uniformly to a continuous function. Okay, excellent. That's the Weierstrass M-test. So now what do we have? We have a bound on the absolute bound on the sum of the absolute values of the Fourier coefficients of f. So let's use that to our advantage now. So now let's consider. So here's the proof of this theorem. So note that f hat of j e to the I j x over here is clearly less than f hat of j, right? And so these are my mn or my mj in this case over here. And these functions over here are continuous. These are continuous functions on negative pi to pi, right? You can open if you want or closed. So I can apply the Weierstrass M-test, and so now I know that these numbers over here converge. So by the Weierstrass M-test, so hence these partial sums, hence Sn f of x converges uniformly to a continuous function. Okay, so converges uniformly. Now, in particular, what can we do? So I'd like to show that continuous function has the same Fourier coefficients as the function f, right? So let's call that continuous function, call it g. Call it g of x. And so now what can I note? I can consider now for any L. So if I look at g of x times e to the minus I Lx, right? What will happen over here is that this, so Sn f of x e to the minus I Lx will converge uniformly to this function over here as n goes to infinity. So there's a uniform convergence over here. And therefore, if I integrate this over here, what's this going to give me? So if I integrate this between 0, so that tells me, therefore, that the integral, 1 over 2 pi, the integral from negative pi to pi of g of x e to the minus I Lx dx is the limit as n goes to infinity of these integrals over here by uniform convergence. Okay. Now, of course, what's this going to extract? This thing over here, by orthogonality, is going to extract f hat of L. So this is just going to be the limit as n goes to infinity of f hat of L, which is just f hat of L. And this thing over here is just g hat of L, g hat of L. So the Fourier coefficients of the function that this thing converges to are the same as the Fourier coefficients of the function itself. So in other words, these partial sums over here, Sn of x, converge to the function itself because they have the same Fourier coefficients. So now, of course, we can use Fourier uniqueness. So by Fourier uniqueness, two continuous functions that have all the same Fourier coefficients have to be the same function because I can convolve with the Cesaro means, and the Cesaro means of a continuous function converge uniformly to the function itself. Therefore, f and g have to be equal. So by Fourier uniqueness, f of x is equal to g of x, and the partial sums of my Fourier series, which converge to this function g of x, actually converge to the function f of x. So we have that Sn of x converges uniformly as n goes to infinity to f of x under this condition that the sum of the absolute values of the Fourier coefficients are less than infinity. Thank you very much.